Good morning, everybody. Welcome to Investigation 2 this week. So, we're going to start this off with today I'm doing a combination of both Investigation 2.1 and 2.2 because you guys are far ahead where you need to be. So, I don't want to waste your time. So, I'm going to do this is example 2.1, the actual example out of the book. So, I'm going to do part A and B of 2.1, had you guys do parts C and D. And then I'm also going to do a quick little lesson for 2.2, which again should simply act as a review for you guys. And have you guys do that as well so that we can be wrapped up with this by Thursday for another quiz on Friday. I'll be with you guys. I'll be seeing you guys from now on this afternoon at 1 o'clock till 2:05 every day in the afternoon. And then you can always see me in the evening at 8 o'clock to 8:30 for any extra questions you might have. So I already wrote down this question, investigation 2.1, directly out of the book with the questions. I think this is a better teaching tool than me making up some examples and having you just redo it. There's more application stuff than the actual ACE, which is starting on page 30. So this is why it's a better tool because the questions are kind of confusing. I want to make sure you guys understand completely what's going on. So you have an original shape here, and then you have the new rectangle here, and then over here we have the difference of the areas between the two shapes. So let's go through and fill it out. So if my side length is 2, my area is 4, okay? That's the square. Well, if I have a rectangle with a length of 4, because now remember, I'm using this whole thing we did last week with this fixed perimeter. My perimeter, if this side length is 2, there's 4 sides to a square, so the side has to be a total of 8, a perimeter of 8. So if that's the case here, 4 and 4 makes 8, which means my width is 0, which means this shape does not exist, so the area is 0, so our difference is 4. We just started off with that basic one. Now it's going up by 2 every single time, and you'll see again, if I get a side length of 3 for a square, well, 3 times 4 is 12. 3 times 4 is 12, right? That's our perimeter. My area for this happens to be 9. Well, my perimeter has to be the same, so that's why I made that example from earlier. Well, if my side length is 5, well, 5 times 1 is 5, that's my area. Well, 5 plus 1 is 6, and the other 5 plus 1 is also 6. 6 plus 6 is 12, which makes this true about the fixed perimeter. Now that we know that, going forward, I can clearly see that this is just 2 squared is 4, 3 squared is 9, 4 squared is 16. Well, this is going to add by 6. Let's make sure that this is 2 because my perimeter has to be 16, just like my area in this case, okay? Well, 6 plus 2 is 8. 8 times 2 is 16. So this makes my width 2, which makes my area 12, and my difference of my two areas is 4. Continuing on, 5 squared is 25. And I can see a pattern here, 4, 5, 6. I bet this is 7. Well, if the side of this 5, my perimeter has to be 20. 4 times 5 is 20. So again, well, this is going to be 3. Because this makes 10. 10 times 2 is 20, which makes the perimeter true. 7 times 3 is 21. My difference of my areas is 4. 6 squared is 36, and I can now see the patterns following true. I'm going to increase by 1 there, increase by 1 here. 8 times 4 is 32, and 8 plus 4 is 12. 12 times 2 is 24, which is 4 times 6, so that has the same perimeter. And my difference of my areas is 4. Okay. Now, I want to continue filling this out, okay? And I want to see right here. It says, write an equation for the side length n and the area A1 of the original box. I want you guys to know we're representing the original as A1, the new one as A2, as you'll see down here, okay? Now, I'll read it again. Write an equation for the side length n and the area A1 of the original box. So, as I can see here, to get my area every single time, all I'm doing is taking this and squaring it. So my area formula for the original, to answer part A, is going to be n squared equals A. Okay, that's your part A from this one right here. Going on, the next question says, write an equation for the side length n of the original and the area A2 of the new rectangle. So, all right, let me read it again. write an equation for the side length n of the original and the area 2 of the new rectangle. So I'm looking here. I'm not going to really look at this to figure out the pattern. I'm looking at these two parts right here to see what's going on, okay? And I can see every single time my area is 4 less than of the new one, 4 less than the area of the original. And I'm looking at that pattern. And now I can see that that's always consistently true. So my answer for part B is going to be, like I just figured out, is n squared minus 4 equals a. So this requires you to really look, analyze, think as you guys are making these things and being accurate. It's not asking us anything about this. Obviously doing this helped us get this, but our answer was reflective of just the areas. And I know this is true because if my side length is n, so 5 square, if my side length is n right here, to get my area, it's always going to be the same. So if it's 4 squared is 16, 16 minus 4 is 12. Hence, this made it true right here, our difference of area, minus 4, if you will. My last question right here says, write 2 different expressions for the area of the new lot. So this guy right here, and this is what you guys have not learned yet, and this is called the difference of 2 squares. So the difference of 2 squares is what's going to lead us into the next problem 2.2, but I want you guys to understand this because I have not taught this to you yet. N squared minus 4. Notice how there's no middle term right there. No middle term means I have a plus and I have a minus, which makes that n thing true. Like for instance, before I get to this answer real quick, if I had something like this, n squared plus 3n plus 4, sorry, let's do minus 4. I'm just making this up right now, okay? If I had this, I have a middle term, so I know that I'm going to have n and an n right there. I got a minus 4 and a plus 3. Well, minus 4 plus 3 means I got to have a negative positive at the end here, so I can do a plus and a minus. Now, which one you make positive and negative is really important here because I have a plus 3 and a minus 4. So I'm going to do plus 4 minus 1 because when I carry out the distributive property, or a FOIL in this case, I'm going to get n squared, okay, one second. I'm going to get n squared minus n plus 4n minus 4, which I combine these two. This now makes n squared. We can all see this. Oopsies. So what I was doing here, sorry about that. I'm just making this clear that I'm breaking this into factored form, and I recognize that I have a middle term right there in case I didn't, because I don't know what part of the video I didn't correlate with this, with your eyesight. Anyway, I broke this down into these factors, knowing that positive 4 times negative 1 makes negative 4, and positive 4 plus negative 1 makes positive 3. So when I add all these up, I'm going to end up with this exact same expression of 3n minus 4. Now I did this to make a point because I'm recognizing I have no middle term right there in this quadratic. So this is called the difference of squares. So this factors into n plus 2 and n minus 2 because I'm going to have no middle term because it's going to cancel off when I carry out FOIL. For instance, n times n is n squared, then this times this is negative 2n, this is plus 2n, and this is negative 4. These cancel off, so I get n squared minus 4. So this is another way to write an equivalent expression. These are equivalent. And for your notes, you can title this difference of squares. Hence, one is plus, one is minus. Call it what it is. Difference of squares. And you'll see this in today's work and the rest of the week no matter what. And it's just 2 ways to write the exact same expression. Again, this was all of problem 2.1, part A and part B. So you're asked to do part C and D only. And then I'm going to pause this for a second, come back with another example for 2.2. Okay, so this is my last example for today's lesson, and it's looks very similar to what you guys are doing today, so I don't want to do the exact same one, just something similar so you understand the language, the way the question might be worded, and how to set up two equations, two expressions, because that's what the bread and butter of this lesson is today. Understanding what two expressions are of the exact same quadratic situation. So I drew this in blue and a little outline black over here and the whole rectangle in blue with a black divided line because I have two rectangles that are, combined together, but they're representative of different expressions. So this first one, I want you guys to write two expressions to find the area of the blue rectangle, okay? Well, my blue rectangle is right here. We don't know what this length is, but I know what the whole length is of blue and black together, and I know the black has a length of 2. So what I want to do now to find for this one, let's call this B, okay? So to write two expressions to find the area of this blue rectangle, I want to do this. I'm going to do x times x, and because this x is the whole length and 2 is taken up within that x, this is x minus 2, okay? Over here, for part B, we'll call this A, we'll call this B so we see the difference. Now, I got my x and I got 5 more over here, so more than is plus. So I got x times x plus 5. There's our first expression I want you guys all to do, hopefully with no issues. Now the next thing, to find another expression, just carry out distributive property. So I got x squared minus 2x, and over here I got x squared plus 5x. So we've learned how to solve quadratics, and today how to set them up in different equivalent forms, and you'll see where this is all going, but just follow all the instructions in today's work, do what's asked of you. It might seem easy for a lot of you, hopefully, and it might be a little challenging for anyone else that's still having a little trouble, which is more than okay. So make sure you come to our Q&A and ask any questions you want, so I can know what direction to go in following today. But I'm hoping that this is making sense, and if it's not, again, that's okay. See me for help and I will help you out.